So we'll start by looking at the vertebral ligaments. It's hard to draw all the vertebral ligaments being a 3D type object, but we just start by drawing a cross-section of a typical vertebrae. All right, so here's the body of the vertebrae looking side on with the spinous process coming down the back. And I'll draw another one for us so we can sort of see how vertebrae might go together. Now, drawing in between the two bodies of the vertebrae, of course, we've got the intervertebral disc which is sitting nice and neatly in between the two bodies. If I draw on some ligaments, we'll start with the anterior longitudinal ligament. So it runs down the anterior or the front wall, right the way down from the very top cervical vertebrae right down through the lumbar vertebrae. So this is the anterior longitudinal ligament represented here. So anterior to the body. Now, we've got another ligament called the posterior longitudinal ligament. So posterior longitudinal ligament, as similar, sort of concept to the anterior longitudinal ligament, runs down the posterior wall of the body of the vertebrae. So this is the posterior longitudinal ligament. Now, the other ones are harder to draw. All right? So we've got one called the supraspinous ligament. Supraspinous refers to on top of the spinous processes of the vertebrae. So the spinous processes being those points that are sticking out the back of the vertebrae. This is the supraspinous ligament. So it's supraspinous ligament. And then we've got something called the interspinous ligament. So inter being in between each of the spinous processes. So if I were to draw that on, it kind of looks like it fills all the gaps in between the spinous processes. Now, what is directly behind the body of the vertebrae? Well, we've got that foramen. So if I'll draw a dotted line here, just to represent where that hole would be running straight down to the spinal cord, running straight down the middle of the hole. And so this is kind of 3D type shape. We've got another vertebral ligament called the Ligamentum Flavum. And what it actually does is it joins the lamina of adjacent vertebrae, so the vertebrae above and below, running down the posterior wall of that vertebral foramen. Now, if we think about where we pivot, the bodies pivot sort of straight through, the body pivots through the middle of the body of a vertebrae. So we know that in general, all these ligaments serve two purposes. Number one, they help to hold the vertebrae together, but also they help to determine or limit direction in certain directions. So the anterior longitudinal ligament, this becomes active when it's pulled tight, which would mean the body would have to start to twist back. So if I draw an arrow on like that, that indicates that when my body bends back or hyperextends, this ligament here becomes taut. The anterior longitudinal ligament helps to prevent hyperextension. And similarly, the posterior longitudinal ligament, which is running down the posterior wall of the body, is going to actually help movement in the opposite direction. So I'll draw an arrow like that. And we can't really hyperflex, because that would involve putting our head all the way between our legs, or some people might be able to, but it's more rare. So really, the way we describe that is the posterior longitudinal ligament limits flexion. But it's not alone in this action of limiting flexion, because really everything behind this central pivot point of the body helps to limit flexion. So that would mean Ligamentum Flavum also helps to limit flexion, the interspinous ligament also helps to limit flexion, and the supraspinous ligament all helps to limit flexion, because it's all behind that centerpiece or that center line through the body. So collectively, all of these are limiting flexion, and it's only this one on the front, this anterior longitudinal ligament, which is helping prevent hyperextension. So ultimately, this is a much stronger ligament. It really has a lot more surface area than any of these. So these work collectively to do what this one role here, or the role this one ligament is doing. But they also play a role in helping to hold this intervertebral disc in. Because if we bend back to hyperextend, this disc is going to want to have a tendency to sort of push forward or displace anteriorly. So the anterior longitudinal ligament, in addition to helping prevent hyperextension of the spine, also helps limit anterior displacement of this intervertebral disc. And the posterior longitudinal ligament is exactly the same. So when we flex, this disc has a tendency to want to push out the back or displace posteriorly. Obviously, that would run sort of straight into our spine, or spinal cord, which would be running through this foramen. It would then obviously impact on us there, causing us great pain. So the posterior longitudinal ligament helps prevent posterior displacement. So we've got a couple of roles here. Ultimately, limiting movements or helping prevent movements. We've got stabilising the joints, and we've also got holding in or helping to hold in this intervertebral disc. So let's have a look now at another view of vertebrae to see if we can have a better vision of what some of these other ligaments look like. So if I draw now a vertebrae looking head on, so an anterior view of a vertebrae, I'll draw two for us. So we're looking straight on this time. We've still got the intervertebral disc in between there. We're going to see a couple of other features. We're going to see the transverse processes sort of sticking out the side of our vertebrae. Depending on which vertebrae we've got, we might see, sort of some facets, sticking up the top, and these ones here we can't see because they'd be in behind this disc. We may see just slight remnants of a spinous process, which is heading away from us, so not a great view to view the spinous process. So if I draw the ligaments we already know onto this, we would see all across the entire front section of the body, from the top all the way down, the anterior longitudinal ligament. So it really does cover that whole anterior surface of the body of the vertebrae. But from this angle, we can also see another ligament, and it's called the intertransverse ligament, and it joins together the transverse process of each of the vertebrae. Now, we know now that ligaments, become active, or they become useful when they pulled taut. So if this ligament here, if we think about what movement it's going to help prevent, it's going to help prevent movement that direction. So that's called lateral flexion of the vertebrae. So when we laterally flex or bending over to this side, this ligament becomes taut or tight, therefore helping to limit movements in this direction. And the intertransverse ligament on the opposing side would help to limit movements in the opposite direction, which is still lateral flexion, it's just laterally flexing to the other side of the body.